Okay, if you could please click that you're here. Is that everybody? Yes? Last call. All right, so now, questions on homework? Yes. I have a mistake in my typo, or a mistake in my solution? Okay, let me check it. Let me make sure I'm in the right class here. Which one's R7? Yes. Which number? 12. Number 12. Y minus. So what are you? When you factor, 2 times 2 is 4, and the other. Oh, did I put the wrong? Oh, I see. Okay, got you. Yes, I see it right here. This should be a 1. Yes. That should be a 1. Yes. Why? Where in the world did I get that from? I don't know. So this is a correction for R number 12, R7. This factoring, I put a 2 here. Yeah. These, there may be errors. I go through these so fast that, you know, my goal is just get them done, get them. I don't go back and double check and not real precise. So they're there to help you. Good for recognizing that. Anything else? R7, number 80. Okay. Here, right? Okay, so I'm multiplying, this is a little different. I'm multiplying the top and bottom of this complex fraction by the LCD. When I multiply here to here, right, this x and this x go away, which leaves you with this, this, and this. That's these 3 right here. You okay with that? So you want me to just get to this one right here? Okay, so look, on the top, you're okay with this one going over here, the x minus 3's cancel. I'm left with the x and the x, which is x squared. I'm left with the x plus 3 that's here. There was a minus between them. Now, I did the same thing on the bottom. I distribute this here to here. So when I multiply this, the x minus 3's cancel right here. And this x times the x squared becomes x cubed. And this is the x plus 3 that's still there. So on the bottom, I'm left with the x cubed and then the x plus 3. It's multiplying this straight across here. Do you follow that? You sure? Okay, going across here? Okay. And then here to here is the same story. The x plus 3's cancel. So I'm left with the x minus 3, the x, that's right here, and then the x plus 1 squared, which is here. Anything else? Yes? Yes, there's an x plus 3 common to both of the terms up on the top, so I pull that out. It's right here. When I pull the x plus 3 out of here, I'm left with the x minus 3 and the 2x plus 5. That's here. When I pull the x plus 3 here, I'm left with this. You're okay with that? And then on the bottom, I pulled out an x. That's here. And then I just clean this all up. What's that? Change the... After I multiply this out, yes. Which required a bit of work over here. Good? Anything else? Okay. We have a lot to do today, so let's get this quiz out of the way. So please just clear your desk. Oh, they're yours. Yep. Yeah, I already posted the grades in Canvas. I mean, I wouldn't recommend you go throw it away, even if you didn't do well on it, because you might want to study for the test and use that as a reference. Okay, let's take a poll here, all right? How many of you feel like you did better on that quiz than the previous quiz? Like you were more... No, go ahead and click it. I'm not going to show you the results yet. Think you did better on that one than the last one? Here we go. Let's see. All right. I guess that's okay. All right, so let me ask you another question. How many of you tried something a little different as far as, like, remember we had talked about changing something, the way you study, the way you prepare? Give me a vote. How many of you actually tried something different than you've done in the past? Okay. Okay, last question then. Y'all done voting? No? For the 40% or so, for the 40% or so that did do something different, how many of you felt that it was it worked out better for you trying something different? I should have about 20 responses here. Uh-oh. I'm asking the people who said they tried something different, did it work out better or not? Okay? All right. I'm just curious, you know. Yes? I'm trying to keep up, okay? I've got all the way up through 3.3 done now. It's kind of what I'm doing just as I'm sitting around at home. If I've got time watching TV, I'm doing solutions. You know, like, I'm going to try and keep up through the whole class. No guarantees. Yeah. Okay. Yeah. Well, the detail might come out a little bit because some of it will be expected, but it'll be more than the book, just an answer. And if it helps one or two students, I'm going to keep trying. The thing is, like I told you, this is the first time I've taught this class 1414. Usually I would have this stuff like ready to go already, but since it's the first time, I'm making it as I go. All right, so yeah, I'll try. Yes? Uh-huh. Okay. Well, good. Thank you for admitting that. A lot of people would be too prideful to say that. Uh-huh. Okay. Okay, good. I'm going to keep, like I said, I don't plan on stopping. I said I might stop, but that's one of my main focuses is to try and keep up with the solutions in this class. Okay? So, have you all ever heard Albert Einstein's quote on his definition of insanity? Doing the same thing? Einstein said, insanity is doing the same thing over and over and expecting a different result every time. So that's like kind of running an experiment and getting a result and then doing the same experiment and thinking you're going to get a different result, you know? So I guess what I'm bringing that up because if you're doing the same thing you've always done in a math class and you're not doing well here, you've got to try something different. You have to, all right? At least try. It may not work out. It may be worse that way, but at least try to change something. All right, we have a lot to go over today. I tried to also prepare you some notes today. I won't always have these. Again, this is a work in progress. But if I have something that I want to give to you, I will print it out and I'll bring it to you. All right? So just pass these around. Let's just get everybody get one of these and everybody have a copy? Everybody have a copy here? Nope, I think there's one there. All right, so today would be considered our first day of new material, although it's probably not new material for everybody in here. So the way that I'm going to approach it with the class is a little bit more formal than just giving examples like I did in the last class. There will be some notes to it, all right? So here's what I've got, all right? The reason why I have these for you is so that you don't have to write this down. I don't have to write this down. We can just kind of read through it and move on, all right? So we are going to be looking at 1.4 radical equations and equations of quadratic form. And I have this broken up. Notice it's 1-4 out of the book. 1-4-1 means this is the first note out of this section. The next one will be 1.4.2, which means it's the second note out of the section. And that way, if you're ever studying with someone or you're on the phone with someone in the class and you want to say, hey, go look at note 1.4.3, that's when he explained it, it's easy to reference, okay? So first thing, solving equations in general, right? Anytime you want to solve an equation, the idea is to first identify what type of equation it is. In a class like this, there's a limited scope as to what we can solve. And I listed out what most students in a class like this would be faced with. First would be a linear equation, then quadratic, radical, rational, quadratic form, and factorable. We are going to focus today on radical and quadratic form and factorable. We are not going to look at rational. We are not going to look at linear and quadratic. Linear and quadratic you should kind of know already coming in here. So let's just keep going. The goal in each of these cases is to determine the value of the variable which makes the equation true. That's what it means to solve an equation, right? You solve for x. That means you're telling me the x that makes the equation true. Some things you need to know before we move ahead. You need to know how to add and subtract like terms, right? Negative 3x plus 4x squared minus 2 plus 4x minus 6x squared minus 3. You collect all the numbers together. You collect all the x terms together. You collect all the x squared terms together, right? And you group them up, right? Everyone should be comfortable with that. Something a little less, I guess, less well-known, forget it. You know what I mean. People have trouble with this. Adding like radicals. So what does it mean to be a like term? Like term meant like x and x can go together. X squared and x can't go together, right? They have to be the same variable raised to the same power. Like radicals, you have to add two radicals together, to add or subtract, they have to have the exact same thing underneath the radical, which we call the, what's the thing under the radical called? Radicand, right? So like for this example, I have root 2x plus 1, and then over here I have another one right here. And I have minus 5 of them. So I can put these two together. So I take one of them, right? I subtract 5 of them, and how many would I have? Negative 4 of them. And so that's how I put those two together. And then I can combine the root x and the 4 root x together because they have the same radicand. So we're basically adding the coefficients. The 1 in front of the root x added to the 4 in front of the root x, that gives us 5. So you should be comfortable with adding radicals like that. Also, multiplying radicals. If I have the square root of x plus 1 times the square root of x plus 1, then it's basically squaring it. And when you square square root, what happens? It basically goes away, right? And you just get what's underneath. You should also be aware that if you square something like 3 times the square root of x, the square root's going to go away on the x, but what happened to the 3? It also got squared, right? So you have to pay attention to that. If there's a number out front and you square, it's going to square that number also. You also need to be aware of things that you can do with the equations. The things that you're allowed to do. Right? Anytime you have an equation, you can always add or subtract something from both sides. Anytime you have an equation, you can multiply or divide both sides by something as long as it's not 0. You're also allowed to raise both sides of an equation to any power you want. You can always do that. But we always have to be careful that if you raise both sides of an equation to an even power, like you square both sides of an equation, or you raise it to the 4th power, or the 6th power, or the 8th power, you're always going to have to go back and check your answers. Always. You need to know how to factor. We've already talked about that. You need to know the quadratic formula. You need to know not only the quadratic formula, you need to know how to use it. So remember that anytime you have an equation of the form ax squared plus bx plus c equals 0, that is a quadratic equation, and you can apply the formula. Now, probably print it out on your page a little better, right? You can read that. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes? Usually, when you use a quadratic formula, usually, but not all the time, you get 2 answers. You could get 1 repeated answer. So if it turns out that the radicand here is 0, then you only get 1 answer. Then these are the common techniques for solving all of these types of equations that I listed before. Linear is the easiest one, right? To solve a linear equation, you basically get the variable by itself on one side of the equation. Moving things around, multiplying, dividing, whatever you need to do. That's like the best case scenario, linear equations. Quadratic equation, our standard technique, is to move everything to one side so that it's equal to 0, and then either factor it or use a quadratic formula. For a radical equation, and that's what today is about, these are going to be our steps. We're going to isolate the most complicated radical we see. Isolate means what? Move it to one side of the equation, make it the only thing on that side of the equation. Then we're going to raise both sides of the equation to the power, which will eliminate the isolated radical. Then we are going to repeat that step if we need to, and then we're going to solve whatever equation remains. So there's only really like 3 steps for today for the radical equations. This step, solving remaining equations and on, that means that what you get after you do these first 3 steps is probably either going to be linear or quadratic. And then you have to go solve that. And then check your answers. If you raise to both sides to an even power, you always have to check your answers. Rational equations we are not going to spend any time on today, but those are the steps that we'll have when it's time for those. And then quadratic form. This may not make a whole lot of sense yet, but you have the steps in front of you. I can refer back to these. When you're trying to solve an equation with quadratic form, you have to make sure first you have 3 terms and that it looks like a quadratic. Then you make a substitution. Then you solve that quadratic in U, and then you back substitute and solve the remaining equation. Again, I don't expect you to really follow that because we haven't done an example yet. All right, but when I do that, I'll refer to this, okay? And then factorable equations, well, you factor them and solve them. And that's it. That's all I have for the notes, all right? So please use this as a reference. When I'm doing problems today, I'll refer back to this, all right? And what I'm going to do is start working problems. My goal is to try and do 16 problems today. I don't know how that's going to go. All right. Quick poll. Ready? Are y'all excited? You know, we didn't talk a whole lot about a very important aspect of this class, and I'm trying not to get distracted because we have a lot to do. But, you know, a course like this, we lose sight sometimes of why we're doing this, right? And really it's because, like, everything that we do in this class is equivalent to me bringing in here a toolbox and showing you, okay, here's a hammer. Anyone ever seen a hammer before? You know how to use a hammer? Here's a nail. You know how to drive a nail into a board? Never done it? Here you go. Let me show you, right? Here's a screwdriver. Here's an impact driver. You know the difference between a screwdriver and an impact driver? Maybe, maybe not, right? So I'm explaining, it's all about these tools, right? Now, are we building anything? We're not. I'm going to show you how to use all the tools, and that's what 1414 is all about. It's all about the tools, how to use the tools, so that when you get to calculus, you can build, right? If you get to calculus and you can't use the tools, you can't build anything. So, you know, it's kind of a subject where, unfortunately, it seems like, what do we need this for? Later on is where you'll actually reap the benefits of this stuff, all right? Okay, first thing I'm going to do, I want us to solve this equation. It's a cube root, 1 minus 2x underneath the root, minus 1 equals 0. Okay, on my notes I gave you, what was the 1.4.1? What does it say? Very first thing there. 1.4.1. Identify what we're looking at, okay? That's the most critical step. I mean, obviously it's a radical equation because we're in the section radical equations, right? But if you're out there in the calculus world, no one's going to tell you, now this is a radical equation, so go ahead and do these steps. You have to identify that. So I look at this, I see a radical, right? See the radical, the cube root of 3, or the cube root of 1 minus 2x. Because it's a radical equation, I know that I need to, now we can go to that, isolate the most complicated radical. I've already done that, haven't I? I mean, the problem came like that for me, right? Prepackaged, ready to go. Oh, wait, no, not this one, sorry. It's not isolated, right? What do I need to do to isolate it? Take the 1 over to the other side. So I got ahead of myself. I thought we had an even easier problem. So now it's isolated, right? Once it's isolated, what do we do? Raise both sides of the equation to a power that will eliminate the isolated radical. So let me make sure that you're all aware of the fact that the cube root really means that we're raising it to the 1/3. Okay, are we all clear with that? That's what the cube root means? Okay, so if I want to get rid of the 1/3, I need to raise this to the 3rd, the 3 power, right? So now I'm going to take both sides of the equation, and raise it to the 3rd. Right, that's what I'm going to do. So on the right side I had 1, on the left side I had the 1 minus 2x to the 1/3. You don't have to switch this, okay, to 1/3. You don't have to do that. You could do the cube on both sides here. I'm just doing this so everyone is clear of what the cube root means, all right? And now using the fact that when you have something to a power, what do you do to these powers? Multiply, and they multiply to be 1/3 times 3 is 1, which is why we do it, right? Because that gives you 1. Anything to the 1 power is itself. So the left side becomes just 1 minus 2x, and the right side becomes 1 times 1 times 1, which is 1. Right? We good? What type of equation is this? Because the step says repeat if necessary, right? That was my next step. Well, I look at this. Do I see any more radicals? No. So I'm not going to repeat the process. So it says now solve the remaining equation. It's linear. So I just move everything, get the variable isolated. So I'll go ahead and, subtract 1 from both sides. What would that give me? 0. And then solving this, divide both sides by -2. 0 divided by -2 is 0. Now, I don't have to check my solutions, although I would encourage you to check your solutions. I don't have to because I raised it to both sides to what? The third, odd power, right? Even powers you need to check. So let me just check it, though. It won't take long to check this. I'm going to do it mentally. Anytime you check a solution, you always have to go back to the original problem, all right? Very important. Checking solutions, you have to go to the original problem. And I'm going to plug in here what? 0. So 2 times 0 is 0. 1 minus 0 is 1. The cube root of 1 is 1. 1 minus 1 is 0. It checks, right? Okay. Let's do it. Yes or no on that? While you're doing that, I'm going to get the next problem up here. Okay, how about x equals square root, forgot a 2 in front of that, 2 square root x minus 1. Okay, what type of equation do we have here? Radical equation, radical, right? So the first step is to isolate the radical. Is it isolated? Yeah, yes, and maybe no. You might be a little bit hesitant on how to handle that too, all right? So let's think through this real quick. If I get that 2 out of there, what am I going to have to do with it? Divide both sides by 2, right? And then your next step would be to do what? Square both sides. So when I divide both sides by 2, I'm going to create a fraction on the left side, aren't I? And then I'm going to have to square it. Do you want to do that, or you just want to square it now and square the 2 on the right side with the radical? It's your choice. You should get to the same answer no matter what. I'm going to square it now. You okay with that? And I'm squaring it, why? Because it's a square root, right? So I'm squaring. So I'm coming in here now, squaring both sides, everything. When I square the left side, I get x squared. When I square the right side, 4 times x minus 1. So that's not technically correct. I have to have that x minus 1 in parentheses. Because you're squaring the 2, right, becomes the 4. You're squaring this, which becomes x minus 1, but then you want to multiply the 2, right? And if you don't put parentheses, you're just multiplying the 4 times what? The x, and you don't want that. Critical little step there. And now what? Repeat the process if necessary. Do you have any radicals? No? Okay, what type of equation is this? Quadratic. How do we solve quadratic equations? Move everything to one side and try and factor. So to move it, why don't we distribute that 4 through first? All right? That's distributing that 4 through the parentheses. Now move everything to one side, so I'll move it all to the left. So moving the 4x over becomes negative 4x, then this over here is positive. And now, because it's quadratic, you have 2 options. Well, actually, you have 3. How many of y'all learned completing the square? Yeah, you can do that too, but I always recommend factoring. If factoring doesn't work, go with the quadratic formula. Does this factor? Yes. X minus 2 times x minus 2. And the whole purpose of doing that is so that we can set each of those factors equal to 0. You get one answer. What is it? 2. X is positive 2. Should I check this answer? Yes, because I squared both sides, right? I squared it. And because I squared it, it's an even power. I need to check it. So here's my check step. I want to check x is 2. I'm going to check it into the original problem, right? I'm not going to come down here and plug it in. Before I squared is when I need to plug it in. So the original problem was the part in black here, so it should be 2. Does that equal 2 root 2 minus 1? So replaced all my x's with 2's. Is this true? Yes. Okay. Yay or nay on that? You can vote. I'll write the next one down while you're voting. Listen, you can say no, and then we can address it, but we need enough people to be on the same page, or I should say we need enough people to be off the same page for us to stop. 2 plus root 12 minus 2x equals x. What I'm doing right now, because the material we're covering today is very mechanical, all right? Very much I'm showing you how to do it, It's not like the sections later where there's going to be more theory behind it. I'm just working like I'm going through your homework, and I'm working problems right next to each of your homework problems so that you have something to look off of, all right? All right, so this is a radical equation, right? So I want to isolate the radical. So how about getting that positive 2 on the left out of there? Subtract it on both sides. Okay, so I will have square root 12 minus 2x equals, how would you like me to write the right side? X minus 2? Okay, now what? It's isolated so you can square both sides. So when you square both sides here, you must square everything on the right side, square everything on the left side. What happens to the left side? On the left, you just get the radicand, right? Which is just the 12 minus 2x. On the right side, I heard FOIL. Yes? So you know, be clear that this up here, x minus 2 times x minus 2, has to be multiplied out, expanded out. You do not just square each one, right? That's like a big, that's like at the math, that gets you into like the math non-Hall of Fame. To do square this. You've got to do this part, right? Okay, so we do that. X squared minus 4x. That's kind of mean. I shouldn't have said that. Okay, so that's what would happen if you expanded it and collected like terms. I'm not showing that step. Okay, what do we have left here? It's a quadratic equation, right? That's a quadratic equation. So you get everything to one side. Now, does it matter which side I go to? No. I'm going to go everything to the right side because the x squared's positive here. I want to keep the x squared positive. So I'm going to add 2x and subtract 12. When I do that, on the left side I'll have 0. I'll have x squared. What am I doing here? I'm adding 2x, so minus 2x and then minus 8. That factors, and then you check each solution. Yes? Okay, dot, 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 meaning that's all I'm showing. I mean, I've gotten you to a point where you should be able to handle it from there. And I mean, this is the way we want math to be. When you get to calculus, right, your instructor hopefully will be able to say, we're working a bigger problem, right, and we get it down to this right here. And your calculus instructor should say, and you can take it from there, right? And you've got that now. Right now in this class, this is where you've got it from, all right? Does that make sense? All right. Quick vote on that. Any questions there? Or any problems?
What's the simplest, I mean, after that?
Yeah, you factor this, x minus 4x plus 2. You set each of those factors equal to 0. Yes? Now, what if it didn't factor? Quadratic formula. Quadratic formula. I'll do one today where we will have to use quadratic formula. Just this one factors, and it's pretty straightforward. Then check. Yes, you would have to check your answers on that one. Yep. Well, was it negative? It would have been, you're checking before -2 that you'd have to check. Yes. The only one that works is 4. -2 doesn't work. All right, so what about this one? Man, I'm trying to cut down on caffeine, and I've got like this huge headache. Yeah, I think so. Did I even bring my drink with me? I didn't. All right, here we go. Now we're starting to get somewhere. So the difference in this problem is what? You have two radicals, right? Right. So the first step, know what kind of equation it is. It's a radical equation. Isolate the most complicated radical. Well, which one of those seems more complicated to you? Okay, 3x. I'm not going to argue with you. I think that they're equally bad. I wouldn't say one is worse than the other than this one has a coefficient of 3 on the x. This one has no coefficient except 1. So maybe this one's uglier. Fine, I agree. Let's go with this one. We're going to isolate it. But before I isolate it, this is something I see people do. Okay. If you square this whole side right here, that means you have to FOIL it. Right? That does not mean you can square each piece. Then you'd be doing that math unhall of fame thing, right? You have to, the only way you can square each one like this is if it's multiplication in the middle. So although that is a correct algebra step to do that, you could. Who wants to FOIL that nasty thing on the right side? Not many of us. But you could try it. I don't recommend. So what we do is we isolate one radical first. All right, so when I isolate, I'll leave this one on the left side, and then what's going to be on the right side now? Square root of x plus 7, then plus 2. Could I have written it the other way? 2 plus the square root of x plus 7. Yes, doesn't matter. The fact that they're both positive, I don't really care which one comes first. Okay, now can we try and square both sides? Yes? Now, yeah, notice on the left side, the good news is the left side, the radical and the square root, the square and the radical are going to cancel each other out. You'll get just the radicand on the left. On the right, you'll have to FOIL or expand. Yes? No, because this radicand is trapped under the root. The only thing that changes when you move it to the other side is that instead of becoming a negative root, it's now a positive root. Yes? All right, so left side's good. Right side, I'm going to take my time with this one, okay, because it's our first one. Like this. That's what it means to square. Why can't you just do square that? Because right now on this left side, I am squaring a single factor, right? I'm squaring a square root. On this side, I'm squaring what? 2 terms, right? They're separated by addition. This one is not separated by addition. Now, what's under the radical sign is 2 terms, but what I'm squaring is the entire square root. So that's why it goes away. Does that clarify what you're asking? Yes? So here, I'm going to show, I don't like to show mistakes, but here's the most common thing I see is that turns into this. So you get rid of the root and you square this one, you add them together, you get this. Okay, that's very wrong. So think about this. If you were grading someone's test, out of 10 points, student who did that, how many points should they lose? Out of 10, what do you think? 2 points off? Yeah, yep. Well, yeah. If it's a bridge that you're building, then, you know, that's important. This is education. You're still trying to learn. It's okay to make mistakes, right? You want to reduce the number of mistakes you make as you go. But to me, this would be a fundamental mistake. This would be a significant error. All right? As opposed to writing this down and then making a mistake somewhere in here. So even just going from here to here shows some understanding of what's going on. Okay. I'm going to stop the polling. I was noticing on my videos the poll like moving and stuff, and I'm like, I don't know what people are doing. So I'm just going to stop the poll, and then when I ask a question, you can answer. All right, so what about this? Let's multiply this out. So on the notes I handed out, I said some of the things you need to know how to do, right? Multiplying radicals. When I take the square root of x plus 7 times the square root of x plus 7, that's the same as the square root of x plus 7 squared, isn't it? Which just means you get x plus 7. So right here, this is going to be x plus 7. Okay, I'll do the next one in a different color. Green. What's that times that? 2 times the square root of x plus 7, which is just 2 times the square root of x plus 7. You can't do anything to that. So it becomes 2 square root x plus 7. You cannot put the 2 inside the root, right? That doesn't become square root of 2x plus 14. Then your next one, which is here to here. 2 times the square root of x plus 7 gives you another 2 times the square root of x plus 7. And then finally, I'm out of colors. I have more, but forget it. I'll just do it in there. There. That one to there. That's 4, right? We good? All right. We've done the raising both sides of the equation to a power. Take a breath. Look at it. What type of, oh, let me bring the left side down here. What type of equation is this? I see radicals. It's still a radical equation, right? It's still a radical equation. So since I'm still working with the radical equation, I'm going to repeat the process. Remember, the third step was repeat if necessary. So what I need to do right now is I need to isolate the radicals. That means I need to get the radical stuff by itself. Now, can I add these two radicals together? Yes, and I get how many of them? 4, because you're doing 2 times 2? 2 plus 2, right? Because you're adding the 2 coefficients. Does the root go away? No, right? So I'm putting these 2 together. I can also put this 4 and 7 together, which would give me, what, 11? So let me write the next line. I've got 3x minus 5 equals, I had x plus 11. Then I had 4 of those root of x plus 7s. That's just cleaning up the right side of the equation. Now isolate the radical. Yes? Where is it? No, because I'm keeping it on the right side. I haven't moved it. It's plus and plus. I'm about to move them to the other side next. Well, I collected like terms here. 7 and 4 is 11. But I have not isolated the radical, so I have not moved those to the left side yet. That's my next step. So I'm going to subtract x on both sides, which would give me how many x's? 2x on the left. I'm going to subtract 11 on both sides, which would give me negative 16. Then I'm left with the 4 root x plus 7. And any ideas here? You could square both sides. Do you want to divide by 4 and create a fraction? Just keep the 4 here? Yeah? It's okay with you? Anyone have a suggestion of what we could do to clean it up a little bit? You could divide everything by 2. Notice that everything has a factor of 2 in it, 2x, 16, and 4. That would make it a little bit nicer when we do square it. I would recommend that step. Divide everything by 2. Remember, when you divide this over here by 2, you do not divide the inside of this by 2. Just the coefficient. So that would leave us with x minus 8 equals 2 root x plus 7. And now let's go about doing whatever we got to do. What do we got to do? Square both sides. When I square the left, I'm going to have to expand that. When I square the right, I'm just going to have to be careful. That's all. So what is the left side there? X squared, say again? Minus 16x plus 64. When I square the right side, 4 times x plus 7, but I need the x plus 7 in parentheses. And then at this point, what do you have? Quadratic equation. And now in this class, dot, dot, dot at this point. Because we've gotten it down to a quadratic equation, right? You would distribute the 4 through, you move everything to one side, and then either factor or use quadratic formula. The answer to this problem is 18. There are 2 solutions, only one of them works. 18 is the answer. So work that on your own. How are we doing on time here? 40 minutes? Let's do a poll here. How many of you feel okay with that? You know what? Let's take 5 minutes. See if you can solve that equation while I go find myself a drink, if you don't mind. Just see if you can solve this equation real quick. Did 18 come out or no? How did I what? How did I do what? I didn't. I haven't done anything. Okay, so it's minus 20x plus 36. 18 and 2. Negative 18, negative 2. You have to check your answer. If you come back up here and you plug 2 in here, 3 times 2 is 6, minus 5 is 1, square root of 1 is 1. Okay, 2 plus 7 is 9, square root of 9 is 3. 1 minus 3 is not 2, it's negative 2. See, and that's what the squaring does. When you, like if I take the number 2 and square it, I get the same as what I do when I square negative 2. So squaring introduces these extraneous solutions. Is it only, did you say it was only for the even number? Only if you raise both sides to an even power. Okay. Yep. Okay, let's do a new one. X squared plus, minus, 16 to the 1/2 equals 9. What do? Get the root by itself, which it is, right? Square both sides. That's x squared minus 16 on the left. What do you get on the right? 81. Now, this is a different type of quadratic equation we have left here. You could move everything to one side and try and solve it. But whenever you have a variable squared and everything else is just a number, it's easier to do what? Move the constants to one side and just take the square root on both sides. So how about adding 16 to both sides? What would you get? 97, right? And then square root of both sides. Now, we talked about this, did we not? When you come in and you take the square root on both sides, you have to do plus or minus. Because you initiated the square root. Yes. Well, you have to check your answers, because we squared both sides, didn't we? In the very beginning? So I'd have to check this. Let's check it real quick. If I take the square root of 97, let's say positive, plug it in right here. What's the square root of 97 squared? 97. Take away 16, 81. 81 to the 1/2 is the same as the square root of 81, which is 9. Now, if I take negative root 97 and square it, what would I get? Positive 97, right? Because negative squared would be positive. So both solutions should work here. You just include one answer, not the other. Yeah. All right, next one. Solve. X to the 3/4 minus 9x to the 1/4 equals 0. Yeah, this means the fourth root of x cubed. This means the fourth root of x. So this problem is different than what we've seen before, right? So see if you can follow this. These are both, we have two terms on the left and they're set equal to 0, right? I'm going to try and factor something out because they both have x's in them, don't they? So what can I factor out? X to the 1/4? Okay, let me see if you can convince me that that's what I need here. If you want me to factor out x to the 1/4, how do I get x to the 3/4 back? I need to have x to what power here? 2/4? What do you do when you multiply two x's with different exponents? What do you do to those exponents? Add or multiply? Add. I need the exponent that I'm going to put here to add up together with 1/4 to become 3/4. 2/4. But 2/4 is really 1/2, isn't it? So I'm going to put this to the 1/2. Yeah, what about over here? Minus just 9? Just 9, right? Because if I come through here and I multiply x to the 1/4 times -9, I get exactly -9 times x to the 1/4. Okay, let's ask if everyone is okay with that or not. Remember, we're going for 80% here. Okay, what part of it? Someone's going to have to break through and yes. So is your question why these two together become this? Well, when you have two x's to different, same base, different powers, you add the powers, right? So I needed to figure out a number that when I add it to 1/4, I get 3/4. So we had said initially 2/4 would work. Because what's 1/4, when I distribute this through, what's 1/4 times, what's 1/4 plus 2/4? 3/4. But 2/4, we never write 2/4 as 2/4. We write it as reduced, right? So that is actually just a 1/2. If you're okay now, please just click that you're okay now. That's right. So, well, nobody writes 2/4. Everyone would reduce that, right? You would have to find it first. Yeah, I mean, I'm using the fact that I need to get to 3/4 to help me see that that's 2/4. And then I say, wait a minute, 2/4 is the half. Up. Yes. 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 Yep. Okay, we're almost at 80. What's up? Someone needs to ask. Ah, that's a good question. Why would I take out x to the 1/4? Yeah, I know, but why? You suggested that, right? Someone over here did. Why? Why, though? How can you tell? Hold on. The question is why x to the 1/4? Why not something else? They both have the fourth, right? They both had a fourth down there? Yes? So it's almost like an educated guess. I mean, like, one is 3/4, the other is 1/4. Let's go with the 1/4. Yes? Yeah, no? Is that what you're saying? Let's try one after this that'll really test whether or not y'all understand this. Okay? It'll challenge even the people who might feel comfortable with this. We'll try something else. All right? Okay, look. At this point, you have two things that multiply to be 0, right? Two things multiply to be 0. Whenever you have two things that multiply to be 0, you set each one of them equal to 0, don't you? So I'm going to set x to the 1/4 equal to 0. The other equation I have is x to the 1/2 minus 9 equals 0. Just like when you factor a quadratic, right? You set each factor equal to 0. Same thing here. How can I get x by itself here, not x to the 1/4? Raise both sides to the 4th power. What would you get if you raised the left side to the 4th power? You get x. How about 0 to the 4th power? Still 0. So x is 0 is a potential answer here. I'll check it. And then over here, what? How about we add 9 to both sides? And then that's basically isolating that radical and then square both sides. Yes?
Can you substitute the x for let u be x, or it doesn't apply?
Not for this one. We're about to get to those. Hopefully, we'll have time to get to it. This will become x equals what? 81. And now we'd have to check those answers. They both work. All right, so I wanted to challenge you for something here. This comes up in calculus. Just curious, could you factor this? We'll say solve. X to the 1/3 minus 5 x to the 3/4 equals 0. That'll probably work. Let's see. See, this is what the point is. You can't pull out the x to the 1/3 like you did earlier, or like the 1/4. So yes, you start by writing them in common denominators. So what is a common denominator between 3 and 4? 12. So I can rewrite 1/3 as how many twelfths? 4 twelfths. Then over here, I write 3/4 common denominator is 12, so change it to 9 twelfths. See how we've just changed these fractions? I'm just rewriting 1/3 as an equivalent fraction with the denominator of 12. So I multiply the top and bottom by 4 to become 4 twelfths. Over here, I want to make that denominator a 12 also, so I multiply top and bottom by 3, which gives me 3 twelfths. Because these both have a 12th in the denominator, I'm going to factor out an x to the 1/12. Or, well, you know what? I can go even more than that. 4 twelfths. Let's see if that'll work. X to the 4 twelfths. What would be left here? How do I get x to the 4 twelfths to turn into x to the 4 twelfths? I need a 1 minus 5 x to the 5 twelfths. So that when you distribute this through, you get x to the 4 twelfths. When you distribute this through, you get -5, and then you add the two exponents. When you add these two up, you get 4 twelfths and 5 twelfths add to be 9 twelfths. So you get back what's up there. And then you go, I'm not going to take this. I just wanted you to see that. The common denominator thing is useful. One more thing I want to show you that's very dangerous. I'm not going to poll you on that because that was just bonus material, okay? How about this one? I've stepped a little bit away from radical equations for just a second because I wanted to address this. One of the biggest mistakes I see, I even see my Cal 3 students do this sometimes, is they'll go to solve this equation by dividing both sides by x. They'll say, okay, let's divide by x. And if you do that, what do you get? X squared equals 1, right? X cubed over x is x squared. X over x is 1. And now to solve this, you do what? Square root on both sides, and you get plus or minus 1 because you took the square root, right? So you get two solutions there, plus or minus 1. So check the answer real quick. Go to this right here and check 1. Does 1 work? Yes? Does negative 1 work? What's negative 1 cubed? Negative 1 times negative 1 times negative 1 is negative 1, and then plug negative 1 in here. Yes, it works. It worked. Okay, does 0 work? Right here into this equation, does 0 work? Okay, why didn't you get 0? You missed an answer, didn't you? Okay, you made the mistake of dividing both sides of the equation by a variable. And when you divide both sides of an equation by a variable, you don't have control over that variable. But what you've told me is that it can't be 0, because you're not allowed to divide by 0, right? So you've lost a solution here by you doing this algebra. This is incorrect to do it this way. So that I always tell students, if you can avoid dividing by your variable, avoid it. Instead, the proper approach to this problem would have been to move everything to one side. So move that x to the left side, and then factor the left side. If I factor an x out, I'll be left with x squared minus 1, like this, right? Factoring an x out of each of these. What's x squared minus 1? Factor that for me. X plus 1 and minus 1. Difference of squares. And then you can set each of these three things equal to 0. And what would your three answers be? 0, 1, and negative 1. And now you have them all, right? Very dangerous to ever divide by something that you don't have control over. All right. Man. What type of equation is this? That's the first thing we always ask ourselves. Is it linear? Okay. Is it a quadratic? Quadratics are squared, right? It's not squared, it's the fourth power. Is it radical? I don't see any radicals, right? This is what we call a quadratic form. This is the first one we looked at today. It's quadratic form. And it's quadratic form in the sense that we have three terms, right? Three terms. And if you squint your eyes just appropriately enough, see if you agree with this. That's x to the fourth. Yes? Okay, I haven't changed the problem. I've just rewritten it so that you can hopefully identify the fact that you've got x squared here. That x squared I didn't need in parentheses, but I'm, again, trying to draw your eyes to the fact that this rewritten has that blue thing squared minus 10 times the blue thing plus the 25 equals 0, right? So it kind of looks quadratic. Kind of. Do y'all see that? Okay, so what we do is we make a substitution. Whatever the thing is in blue here is going to be what we substitute. And we usually like to use the letter U. So this is what you were referring to a little while ago. I'm going to say let U be, go ahead. It's always good to try and rewrite the equation so that it looks quadratic to you. All right? And that'll help you identify what it is that is going to be replaced with U. So everywhere I see x squared, I replace it with U. What would this equation turn into if I make that substitution? U squared minus 10U plus 25 equals 0. Okay, let's take a poll real quick. Are you okay up to this step? Yes or no? Okay. I guess we proceed. I do see you over there, you 13%. I'm not totally not being compassionate, but we have to move. So at this point, this quadratic equation you should be able to solve, right? You either factor it or you use a quadratic formula. The important thing, though, is that this quadratic equation, the variable here is u, isn't it? Our original problem was in x, right? So I'm going to go through and solve this. I'm not going to dot, dot, dot this one. When you factor the left side, you get u minus 5, which is the same root, the same solution, so you get u is 5. Okay. We do not write this as our answer and box it, okay? It's because our original problem was what? In terms of x, right? You're going to replace u with what it was. So come back up here. What was u? It was x squared. So I just replaced the u with x squared. So I'm going back to the original variable, leave the other side of the equation what it was, and now solve this equation. Square root on both sides. X equals plus or minus the square root of 5. That's your answer. And we would check those solutions. I'm not going to, but we would check them. Okay, tell me how you feel about this, yes or no? Okay. Next one, I've got about 15 minutes left. Let's see if I can knock out the next few. Solve this. Three x to the negative 2 minus 7x to the negative 1 minus 6 equals 0. So we're asking ourselves, is this a linear equation? No. Is it quadratic? No. Is it radical? No. Is it quadratic form? So I'm thinking quadratic form 3 terms, right? I mean, that's always what I'm looking for, quadratic form. And then the question is, can I make it look like something u squared, then the middle term having just u in it? So I got to figure out what the u is if I'm going to make a substitution. Do y'all see what it is here? X to the negative 1. And if you go back to the one we did before, what was our u here? Looking up here, it was the x squared, wasn't it? And this next one, it's going to be the x to the negative 1. Now, let's confirm it. I need to be able to write this as x to the negative 1 squared, right? Is that correct? Is x to the negative 2 the same as x to the negative 1 squared? Yes. And then minus 7 x to the negative 1 minus 6 equals 0. What's my u going to be? U is equal to x to the negative 1. And rewrite the problem in terms of u. 3u squared minus 7u minus 6 equals 0. Does it factor? No? I think it does. Let me use a quadratic formula just for this one, okay? You can factor it, but we haven't used quadratic formula, so let's use it. Because I want to point something out here. The quadratic formula says x equals negative b plus or minus square root of b squared, all that crap, right? It says x equals. But our equation is in u. So we need to write what? u equals, not x equals, negative b, 7, plus or minus the square root of b squared. What's b squared? 49, right? Minus 4 times a. What's a? 3 times c. What's c? Negative 6, all over, the whole thing over 2 times a. That would be the application of the quadratic formula to this quadratic. It's on the notes. That's your A, that's your B, that's your C, right? That's A, that's B, that's C. And then just plug into the formula. So let me see what I get here. 7 plus or minus the square root of, I like to do these three numbers first. What do we get? 72 here? Plus because it's two negatives. So plus 72. So what's 49 plus 72? 121. And 121 is a perfect square, isn't it? So the square root of 121 is 11. So we get 7 plus or minus 11 over 6. And now we look at the two possibilities. What's 7 plus 11? 18 divided by 6 is 3. Or now 7 take away 11. Negative 4 over 6 is negative 2/3. That's the same as negative 4 over 6. So you're getting two things, right? U is either equal to 3 or U is negative 2/3. Yes? But we made a substitution, right? You don't want to forget this. U was x to the negative 1. So I need to go and now switch back and say x to the negative 1 equals 3, or the other one, x to the negative 1 equals negative 2/3. Yes? I want x by itself, don't I? Whoa. I want x by itself? I don't want x to the negative 1, right? I want x. So how can I make it a positive 1 here? I could raise both sides to what power? Negative 1. Couldn't I? Like if I do that, then I multiply these two. What's negative 1 times negative 1? Positive 1. So that would give me x. But I have to do that to the other side. So the left side would turn into x. The right side would turn into, what's 3 to the negative 1? 1/3. 1/3, right? 3 to the negative 1. You drop the 3 down. And then this one over here, same story. Raise both sides to the negative 1. Now be careful on that on the right side there. Left side's x. What happens if you take a fraction and raise it to a negative number? What can you do? Flip the fraction over. That's it, right? Doesn't change to a positive. This is negative 3/2. Those are your two solutions. You check. Let me see. They both work. They both work. Now, with these substitution problems, they can come in different formats. Let me help you. I'm not going to do this problem. I just want you to see it. Go ahead with your question. Oh, scroll up. Okay. I want to give you another variation of this. Again, I won't go through the whole thing, but I want you to see it. All right. Good? Okay. So what if you had solve 3x to the 4/3 plus 5x to the 2/3 minus 2 equals 0? Quadratic form or not? What are you thinking you're going to use as your u? X to the 2/3? Well, let's try it. It would have to be 3. Then you're saying it's x to the 2/3? I need to be able to square that and get 4/3. Is that right? It's 2/3 squared. X to the 2/3 squared going to give you this? Yes. And then rewrite the rest of it. So what would your substitution be here? U is x to the 2/3, and then you'd rewrite the quadratic. It would turn into what? 3u squared plus 5u minus 2 equals 0. You go through, you solve that, however, factor or quadratic formula, whatever works, and then, very important step, switch back, right? You got to switch back to x. Remember, if you don't switch back to x, it's like me asking you your favorite color, and you're like, Ford. You know, it doesn't make sense. We're asking for x, and then you're like, u is equal to 2. It doesn't make any sense. So you have to get back to the original variable, or else you have not achieved the goal, right? Okay, there are a couple of problems that I don't think I'm going to get to, but they are factoring by grouping, which I'm assuming most of you have seen. So I'm just going to make a note of this. In your homework, the problems that are from 73 through 86, this is a lot of these can be done by just factoring GCF, greatest common factor, and grouping. Do y'all remember grouping? Where you have 4 terms, you split it down the middle, you factor something out of the first 2 and the second 2. I'll let you go back and review that. Just go Google factoring by grouping or something. Because I want you to see this last type of problem, all right? I should finish it up before time's up. All right, I'm just going to write it the way it appears in the book. If k is equal to x plus 3 over x minus 4, and k squared minus 3k equals 28, find x. No, find x. There's a couple ways to do this, so I'm going to take advice from the crowd here. The second equation is a quadratic, which you could solve for, right? If you solve this, what variable would you be able to get here? You would know the value of k, wouldn't you? Yes? But they want x. Okay, then I could plug that k in, whatever I got from here, I could plug it into here and then solve for x. That is an approach. I like that approach. There's another approach. Rewrite this and just replace k with this. Either way, it'll work. Does that make sense? What I want you to look at it, the way I would like you to see it, is the first approach. It's almost like the u substitution we just did. Remember a minute ago we said, oh, that looks quadratic, and we said u is equal to this thing? It's almost the same problem, except instead of calling it u, we're calling it k. We're saying, oh, we had something nasty, we're replacing that thing. Instead of u is that thing, we're making it k. We solved this quadratic to begin with. Does that factor? Please factor. Yes? Plus 4 minus 7, which means that k must be negative 4, or k must be 7. Now I know what k is. I'm going to go back and use the information I have about k right here. So replace this k with what here? Or, yeah, replace it with x plus 3 over x minus 4 equals negative 4. And then on this one, replace the k with the same thing, x plus 3, x minus 4 equals 7. What type of equations are those? Rational equations. We actually haven't looked at these too much. But to solve this, I would multiply both sides of this equation by the denominator, x minus 4. So I'm going to do this one right here. I'm going to take x plus 3 over x minus 4 equals negative 4. I'm going to multiply both sides by x minus 4. Why do I do that? What's going to happen on the left side? Goes away, right? That goes away. On the right side, can you actually multiply this out? Sure. So what we'll have left is on the left side, x plus 3, right? On the right side, distribute negative 4x plus 16. What type of equation is this? Linear, right? It's a linear equation. And you can solve that for x now. What would we get? 5x. Move all the constants to the other side. 12. No. 13. So I'm adding 4x to both sides. I'm subtracting 3 from both sides. And finally, divide through, and you get 13/5. You think you could do the other one on your own? I'm talking about this one right here. Think you could do that? Yes. Okay, quick poll. Was that one okay? Well, his nose popped up there quick. We're going to do one more quick poll before we go, all right? Here's what I want to know. I'm going to stop this poll. I'm going to save that session real quick. What's today? The 27th? Okay, so what I'm going to do now is I'm going to open an anonymous poll. Okay, this is an anonymous poll, so it's not linked to anybody. Well, someone hit their, let's see if this works, anonymous. Someone hit their thing right now. No, it's, well, let me try it again. Reset session. Oh, man, can't do it. Oh, it didn't? You will not collect item. Okay, that's what I want. Poll. Okay, yeah, this is anonymous. Okay? Do y'all believe me? Okay, so all I want real quick, yes or no, is whether or not this format of the class is working for you. Like me being up here recording. Hold on, let's finish. Me being recording, doing this polling stuff. Is this, or the other option is to actually do like a traditional lecture. I can do that. That's no problem. Sometimes I feel a little disconnected up here when I'm doing it. So if you're okay with this, green. If you think that it might work better a different way, then no. And I won't be able to go back and look at this. I'll let you finish polling. I'd like to get, what are all those other answers? Just yes or no. Like, yes, you're okay with the way things are. No, you'd like to maybe see some change. I'd like to get full responses. Okay. Make sure you drop off your clickers and get out of here. Your homework is in the schedule, right? 1-4 is the homework. You should be able to handle all of it. The solutions are up there for you.